Welcome back. I didn't quite finish talking about everything I wanted to do on Stockfish last time, so I'm just doing a very brief video looking a bit more detail in Stockfish, compiler options, what will be good for your machine, and then using this new function Speedtest just to see what's best. Okay, so going back to where we were before, you can see over here the VirtualBox Manager has Chessnix 1, which is what it's called, powered off, so we can go right into that. And that will start up our virtual machine, hopefully over there on that window. Yep, good. Booting up Ubuntu. And we'll just get it logged in. Okay, so one interesting thing about there is VirtualBox is if you go over here, just here's the normal sort of power down options, you can actually suspend it, which is a bit like sleep, and then it saves the stored state as one of the virtual machines in VirtualBox Manager, and then later on you can just restart it and it'll be exactly where you were when you left off, which can be quite useful. Oh, we're not doing that. So what I wanted to quickly do is let's just as I say, I spend a lot of my time in terminal. Remember, the directory we're looking at is chess, and within that at the moment we've got Stockfish, so we'll just cd in Stockfish, and then src. Obviously we could do a link to it and go straight in there, and that's where Stockfish, you can see the word in green, Stockfish, that's where the executable resides. Now just wanted to sort of highlight that. So there's all the source code, bitboard, search, movegen, all these functions, which are actually reasonably descriptive in terms of what they do. So I just have this other website open, which is worth having a look at when you want to investigate these different sort of steps which are involved in a chess engine. Chess Programming Wiki is what it's called. You can see the web page there, and it talks about a lot of these things. You can see hot topics, Stockfish, neural networks, Leela, and the endgame table bases. So enjoy. That's a very informative website. Now, thinking more specifically about running Stockfish on your own machine and trying to get it as optimal or quick as possible. Let me just see if I can make this full screen using the Windows function. Okay, and normally you right click, display settings, and then I just make it full HD to match my screen. That should be beautiful. Good. Okay. Now, before, remember, make is the function you run when you want to build it. Now, when we did the build earlier, we used this basic one, the least optimized, if you like, arch equals x86-64. Now, Stockfish has this weird function. Now, you always put this dot on the front, which means run the program in the current directory. Speedtest is what we're going to do, and we're going to use one thread. And we let that run. You can see it as warm-up position, and then it'll run for about between 1 and 2 minutes, testing lots of positions, obviously searching ahead, working out how many nodes per second your machine can do. So I'll let that run, and then when it's finished, I'll probably chop this bit out. When it's finished, we'll see how sort of the base compile options give us in terms of speed and so on. Okay, welcome back. So let's see what we've got here. This tells you all the sort of the relevant information behind the test. So architecture, x86, compilation settings, only 64-bit and only SSC2. I think that's superscalar. Superscalar is where the process is doing more than one thing in one step. That's sort of one optimization. And then the other one, which we will get in the next compilation settings, is the real pipeline processing, where it's processing different steps of many processes at the same time. So Speedtest, it shows you there was one thread, and then it gives you 128 megabytes for the hash per thread. And what did we come out with at the end? We've got 600,000 nodes per second. It's okay, but it's relatively low. So what we need to do here is, I'll just do make clean. I don't know if that's necessary or not. And then we will do the make setting with, it's actually not shown here, make -j profile build. You can see sort of the way it talks about it there. And we're going to go arch equals native. Right, so let me get that running. And what that does is it will use the sort of the best options available for your processor, right? Which is pretty much what you want, right? Whichever vector processing and superscalar technologies are available on the 5900X, which is what I've got, it'll use them in the compilation settings. I think it takes about 30 seconds to compile. In fact, you could see it did a quick speed test in there anyway as it flicked by. But we'll wait for this to come back. There we go. And then now what I'll do is I'll run exactly this, just up arrow to bring back previous instructions. I'll run exactly the same speed test, but now with the new version of the executable, and let's see what we get this time. Okay, welcome back. Let's have a look what we've got here. You can see all these compiler options it threw in. Bit manipulation, AVX2, which is I think a 256-bit version of vector pipelining, lots of SSEs in there, and pop count, counts the number of bits in a word, seems useful, don't know why. Speedtest 1, and what do we got? 1.3 million nodes per second, which is very nice, sweet, right? Almost twice the first run. So you can see it's pretty important to make sure that the executable you have is optimized for your machine, which is great. Now the next thing to do is, well, that was one thread, one processor. That's the way they've interpreted it. So you can see in the user invocation, I said 1, but there are 0 to 11. There's 12 processors available, because if you remember back, I gave VirtualBox 12 threads or cores to work with. Well, anyway, half the machine. Now, so we can run it with more threads. Let us make it run with 10. I'll leave a couple of threads around for doing other stuff. Always best. And we'll run that and see what we get back. Okay, welcome back. So what's the result? We get 12.3 million nodes per second, which is nearly 10 times the single thread result. I mean, I think the point here is that the computer here is a desktop with an all-in-one cooler, so it doesn't get throttled back particularly. Just 10 cores, it's still only half the computer. Obviously, you could ramp that up, and then the more you ramp it up, the hotter the CPU would get, and the more your power draw would be. So, I mean, there's obviously cost to really going to the limit on that. A few things you can play around with, which I've done before on this machine. You can lower the voltages a little bit on the BIOS, or get the fastest RAM setting, and so on. Your mileage may vary. But anyway, 12 million nodes per second. I'm sure that is more than enough for almost all practical purposes for people looking at things. Not for the pros, of course, but. Anyway, so that was good. I just wanted to give you a tour of how you could sort of compile Stockfish, give you the best results on your machine, how you can get the best results on the machine, and then the codes there, you can sort of, have a look and see how that fits in with all the theoretical articles on chess programming wiki. Okay, great. Thanks for listening.